It's a very interesting UPSC problem. Uh, this is the examination to be IS and IPS officer, and of course there are many other departments. Let's see, as an engineering entrance examination candidate, how will you attempt this question? Of course, the examination is a subjective examination, so they have given two questions, two part to the questions to verify this. So the question goes like this. We have a matrix A, and the first part is to verify the Cayley-Hamilton theorem, which basically we do at JEE level as well. And the second part is to show that for this matrix, A ka power n will always be equal to A to the power n minus 2 plus A square minus I. So this is one part of the problem. For any n greater than or equal to 3, where I is an identity matrix as usual. And the interesting part, which can be definitely asked in J, is A to the power 40. So let's enjoy this UPSC 2023 question. This is a recent question asked by Union Public Service Commission. There they keep maths as optional. So if you are maths enthu, you can even write those examinations. Anyway, so A to the power 40. So A to the power 40. Usually, the basic style of finding A to the power 40 is to do A square A cube and try to see if some repetition is there in the pattern. Or maybe A square becomes null matrix, then it's A to the power 40 is also going to be null. Or maybe you have to do with patience. A square is not null, but A cube becomes null. And then still you can write A40 in terms of A. Or the other thought process can be the powers of A becomes identity. So usually in most of the JEE problems, these higher powers of A turns to be really nice. Either it's a null matrix, which is 0, or it's an identity. Here if we'll give a try as usual, and if we'll calculate A square, so let's first have fun in JEE style. Of course, you can't do this in UPSC paper because this is a subjective examination and it is totally 10 marks question, unlike 4 marks in JEE. If JEE has to ask, it will be a 4 mark question. Moreover, they'll give 4 options in a multiple correct. Okay, so how will you approach A to the power 40? So maybe we'll try to calculate A square. These two matrix, what we are going to get is the first row will multiply with first column, and that gives you 1. Right? The second similarly row will multiply with second column, which gives you 0, 0, and 0. So you have 1, 0, 0, 1, 1, 0, and we clearly see 1, 0, 1. So this is what we'll get for A square. So clearly that's not a null matrix at all. What about A cube? So if we take this one, we take the matrix, we'll further multiply with A. So we are going to get the first row, we'll get first column, that gives you 1. And we have 0, 0, 1, 0, 0. So let's take A cube. So first row multiplies this one. So we have 1, 0, 0. Then we are having 2, 0, 1. And third row, as you can see, is 1, 1, 0. So it's very unfortunate that given A cube is not dying, right? And similarly, if you want, you can try for A4 and it's surprising, like it's not dying. So you can't definitely calculate it to the power 40 directly. So we can take a hint from the first expression actually. And that's why like creating this kind of paper is more scientifically better than those of JEE problem where directly they ask you to calculate A40. Of course, seeing the competition, it's fine, but at least the hint is given in this problem to go via first method. So as you know, you can even verify the first part of this problem by putting A equals 3. So as we know, the characteristics equation of this is A minus lambda I, and which is basically Cayley-Hamilton theorem. So every matrix will satisfy its characteristics equation. So we can find A minus lambda I, which is basically theorem. And every matrix is going to satisfy its own characteristics equation. So if we'll multiply, we are getting 1 minus lambda into lambda square minus 1 equals 0. So which amounts to lambda cube minus lambda square minus lambda plus 1 equal to 0. Now we know a matrix will satisfy the characteristics equation, so which amounts to A cube minus A square minus A plus I minus A square minus A plus I, which is satisfied, and this direct result of Cayley-Hamilton theorem. Now we can find the higher power. So basically we have A cube, A square plus A minus I. So A4 if we'll calculate, just we are gonna multiply the previous equation with A. So if you multiply this with A, we'll have A cube plus A square minus A. Now make A cube substitution from the previous equation. A cube is this one, A square plus A minus I plus A square minus A. And that gives 2A square minus I. Now we can similarly calculate for a5, a6 and so on. So a6 we are getting 3a square minus 2i. If we'll do for a8, I'm not doing for odd number because our target is to get to a40. So maybe we'll sense some pattern while finding this. So a8 is 4a square minus 3i. We have a10, which becomes 5a square minus 4i. And now clearly you can see the pattern, right? a12 is going to be 6a square minus 5i. So and so forth, so on. So now we can sense the pattern. So when power was 6, it was half of that and one less. When it is 8, half of this, one less. It is 7, half of that, one less. Right? When it's 12, half of that, one less. But when it is cube, you can't write this as something a square plus something. So for all even power, I'm able to write some even number times a to the power half of that even by 2, and minus that number one less than that, right? One less times I. So this is the basic like pattern that we are getting here, and that amounts to simply a40 is going to be half of that, so which is 20a square minus 19i. And now we know the value of a square because a square just we have calculated. So this simply will plug in that expression. So let's plug there. So it's 20 times of 100, 110, 101 minus 19 times of 10, 010 and 001, and this gives you 100, 20, 10, 20, 0. Of course, now one of your question will be, is it allowed in this examination to tell that by using pattern you are getting the answer? Of course, it's a subject exam, so that's why you have to prove the first part. Okay, so the first part, how usually we'll prove? One way is like finding pattern, which is a basic way of doing this thing, but finding pattern is not rigorous because as a mathematics, but finding pattern is not rigorous because as a mathematics guy, I'm not forced to believe like pattern will not break maybe after 365 days or maybe after 365 iteration. What's the probability that pattern is not going to break, right? So just because it works for n equals 1, 2, 3, 4, 5, to generalize it like it will work for every n will be too quick and like it will be too superstitious to believe it. Hence, we want a very rigorous mathematical scheme to prove this. And the first part is proved by induction. So what we do, you show it that it is valid for n equals 3, which is a direct consequence of Cayley-Hamilton theorem. Then you assume it to be valid for n equal to k. And from there, you extract the information that whenever it is valid for n equals k, it's also valid for n equals k plus 1. And that's how we solve the first part of this problem. Now, one small way of solving the second part. So I'm trying to give you a solution from other way also. So one of the JEE candidate can also solve in the following way. He will try to break this matrix into identity matrix plus something. And that's a usual matrix trick to find higher power, right? The motivation is like if you want to find a to the power 40, it will be equivalent to finding I plus b to the power 40. And then maybe like there is a square and a cube is not so nice as we have found, but might be like b square or b cube is another matrix. And then we can easily directly use the binomial theorem because b and I is commutative. Bi can be written as ib. Hence, now we can treat this expansion as if it will. Hence, we can treat this expansion as if it were a real number section y, because whenever matrix is commutative, the essence of being matrix is taken away and the behavior is more or less just like real numbers. So maybe when I'll expand, we'll get I40 plus I39b into 40 choose 1 and so on and so forth. And maybe like b square is dying or b cube is dying. But here, unfortunately, in this case, again, the powers of b doesn't seem to die fast. Like maybe it will die at b5 or whatever, but at least b square and bq you can check is not dying. Okay, so here again you need to have patience to calculate it. So the better method was Cayley-Hamilton and then going by that recursion. So the idea is like you can keep I as 100, 0 1 0 0 0 1, and then it's just 0 0 0. To get 0 1 0, we need minus 1 and 1. So to get 0 1 0, we get 1 and minus 1, and we should have 1. And thereafter we have 0 1 and minus 1. Okay, so this is how we can put this, and again matrix B is not nice. So I hope you must have enjoyed the problem, and the takeaway was very clear. Like usually we solve this problem by taking few powers and generalizing it, but many a time that methods might not be too much reliable, and that case is better if you know Cayley-Hamilton theorem. The other way of doing this problem is something called diagonalization. Diagonalization is a very fanciful idea. So I'm not going to do this, but in some lectures definitely will throw light on that. So the idea of diagonalization is like this. By some crazy method, if you can convert this matrix A into some crazy matrix, into some diagonal matrix like a star, hash, or whatever. Diagonal matrix are those matrices where only diagonal terms are alive and rest term are 0. Into the inverse of, like that GOLU, which is basically you can also find like these two guys are inverse of each other. So if there exists some other matrix GOLU and GOLU inverse, or GOLU transpose, okay. In this case we can come with inverse also. In some case transverse is becoming inverse when the matrix is orthogonal. Yes, very good. So if it is possible to like write this in this form, it will be too good for me, because directly then a to the power 40 will be GOLU times that matrix to the power 40 times GOLU inverse. Okay, because if you'll do just simple matrix multiplication, you will see like GOLU and GOLU inverse is not going to impact the answers 40 to the power 40. And taking powers of diagonal matrix is a very routine job, because just the trace will get powered by that factor. Okay, so now how will you guarantee like there is existence of such GOLU and GOLU inverse or GOLU and GOLU transpose? That can be done by something called eigenvalue problem, which I have discussed in one of the lecture, but diagonalization concept is left to you as an exercise if you are interested, although it's not within the JEE purview.